Hello everyone. In this video I'm going to start modifying the source code from part 1 by adding some graphics, then adjusting the graphics to get the look I want. I'll also do some general tuning up of the script to make the script run a little bit better and look a little bit better. So first of all, I've made a copy of source.py and named it game1, in case I still need to reference the original source code. Then in my game1 script, I'm going to get rid of this camera slack variable and this camera x, camera y global statement. None of these variables are used, so all they do is potentially make the script more confusing and less readable, so we'll get rid of those. The next thing I'm going to do with the source code is change this for loop that draws the black background. In my opinion, using for loops, especially for loops within other for loops, can be kind of slow. And the fact that this loop performs over 1000 blitz every update probably doesn't help anything either. Since this is going to be a video game, you want to be mindful of the script's performance. I would avoid using nested for loops in the main game loop unless it was truly necessary for some reason. You'll also want to try to animate your game using as few blitz per update as possible, so we definitely don't want to do 1000 blitz every update just to draw the background. We can draw the background using only one blit. All we have to do is resize the black background square to be the same size as the screen. So we'll comment out this nested for loop and blit the background surface to the screen at 0, 0. Then we'll scroll up and set the BG surface to be a surface that's the same width and height of the screen. If you want to convert a surface when it's created, you can add this .convert function to the end of it, and it'll work the same as calling it on the surface after it's created. I'm not going to fill it with black because that's the surface's default color anyway. So when I run the program, it'll look exactly the same, but it will perform a lot better even if you can't really tell it all. So next we'll do something a little more exciting and add some graphics to the game. All these platforms are made of gray solid color blocks which look a little boring. So I did a web search and found a more interesting block to look at. I picked this image of a block from Super Mario Bros. For the NES since it happened to be a 32 by 32 pixel image. That of course would make it the same size as the gray blocks I'm already using, so that will make it easy to import this graphic to my game. As you can see in my project folder here, I have created a media folder and then a graphics folder to keep my block image in. So now that I have the graphic in my project folder, all I have to do is take my game script, scroll down to the platform class, and set its self.image property to pygame.image.load media/graphics/block.png.convert. This string argument in image.load is of course the path to the block file in my project folder. What this load function will do is create a surface from the image file and save it to self.image. Since the image file is 32 by 32 pixels, it will be a 32 by 32 pixel surface, so I don't have to do anything about changing the size of the platform's rectangle to match the size of the image. All I have to do is run the script and I'll have a little more interesting looking game. Since now the game kind of looks like Super Mario, I decided to get a Mario graphic to use for my player object. Once I have the Mario graphic in my graphics folder, I can go to the player class in my script and load it into the game using pygame.image.load, just like I did with the block image. Although unlike the block image, the image of Mario isn't 32 by 32 pixels. The image for Mario is actually 16 by 32 pixels. So I also have to change the self.rect property to match the size of the image. Otherwise the player object will be larger than the image that's drawn on it and the collisions won't look quite right. Since the Mario graphic is 16 by 32, it's as tall as the block image and half the width of it. This will make Mario appear pretty small on the map. I definitely know that Mario will need to be larger, but I'm not exactly sure how large yet, so for now I'm just going to double his current size, and I'll do that by using this pygame.transform.scale function. This function will take a surface and resize it to whatever width and height I want. So the first argument is self.image, which is the surface I want to resize. Then I have the width as 16 times 2 and height as 32 times 2, because I want the surface to be twice as large as its original size. Then the surface that's returned by this function is saved as self.image. So now the self.image property will be the resize surface. Since the surface is now twice as large, I also want to make the width and height of the player rectangle twice as large so that the detectable area of the player object will remain flush with the image. So now Mario looks a little better as far as size goes, but he does have this colored background behind him that should really be transparent. There are a few ways to make surfaces transparent in Pygame, but for this particular graphic I'm just going to go with the easy way to do it. If I open up the graphic of Mario in the graphics folder, you can see that this image file does not contain a colored background. This is because this image file contains something called per pixel alphas. What this means is the transparency for the pixels in this image is embedded into the image itself. Each pixel in the image contains an alpha code that says what its transparency should be. So the pixels around Mario have an alpha value of 0, meaning they are fully transparent, and the pixels on Mario himself have an alpha value of 255, which is fully opaque. When I loaded the image into Pygame using image.load, I also called the convert function on the image, which makes the surface have the same pixel format as the display, but calling the convert function will also remove the image's per pixel alphas, which is why the image appears with a colored background behind it when I run the game. When the image is converted, all the per pixel alphas will be removed, and instead of having alpha values per pixel, the entire surface itself will just have one alpha value, which means you can change the transparency of the entire surface, but not the individual pixels, which really doesn't help at all in this case. So what do we do about that? Well, calling this convert function isn't actually a necessary step. The only reason you want to use it is so Pygame can blit the surface a little faster. So if you don't call convert, the image's per pixel alphas won't be wiped out and the image will appear with its proper transparency. Although the advised way to convert a surface while retaining the per pixel alphas is to use the function convert_alpha. This function will retain the per pixel alphas while still formatting the image for faster blitting. So if you're using an image with per pixel alphas and you want it to appear correctly, you either need to not convert it or use convert alpha. Loading the image with convert alpha will make it so Mario appears in the game with the correct transparency. The game looks a little more like it could be a real game starring Mario, but it doesn't really look that much like a Mario level. If you're imagining a Mario level, this map looks like it's kind of zoomed out. We can see more of the platforms than we would expect to see in a Mario game. So what I'm going to do next is change the game's window size and the size of the game objects to try to get a resolution that's similar to Mario. Since this is going to involve changing pretty much every object in the game, I've made a copy of my current script so I don't lose the work I've done, and I can make changes while still having a backup in case something goes wrong. The first thing I'm going to change in the new script is the size of the screen. These window values aren't exactly arbitrary. They are both multiples of 8, which most standard resolutions are, although there's no reason the screen needs to be this particular size. In my project I used this Castlevania background to get an idea of what the screen size should be, so I'm just going to use this background again. If I cut this background into 32 by 32 pixel squares, I can get an idea of what this background looks like compared to how the screen in my game looks. If I want my screen to look like this background, then I can do that by changing my screen size to be the same size as this background image. This background image is 256 by 228 pixels, but if you look at the grid lines near the bottom, you can see that there are some squares that aren't 32 pixels tall, which means the height of this image might not be a multiple of 8. So just for the sake of keeping with resolution standards, I'm going to reduce the height to the next nearest multiple of 8, which would be 224. When I run the script with the new window size, the game screen does look like the background. It's 732 pixel blocks tall and 832 pixel blocks wide. The screen matches the background, but is also very small, which is really not that great for playing a game in. So now I need a way to make the window larger, but keep these blocks the same size in comparison to the window. I think it might be possible to create a zoom effect by blitting all the game objects to a temporary surface, then scaling the temporary surface to match any size screen I want. Then I could blit that surface to the display rather than blitting directly to the screen itself. Although the solution I ended up going with was increasing the window size and the size of all the game objects by the same amount. So in my game script, I'm going to multiply the window's width and height by 3. Then I'll multiply the player's starting position by 3, since all the platform blocks are going to be larger. And position 32 would end up starting Mario inside of a wall. Then the increase in the amount of X and Y in the level builder needs to be multiplied by 3, so it will create the proper spaces for the larger blocks. The total level width and height need to be multiplied by 3, since each character in the array is representing a block that's going to be 3 times larger than it was. Then I'll scale the Mario image to be multiplied by 3 instead of 2 to keep it consistent with the scaling of the window. Also, the rect attributes need to be multiplied by 3 instead of 2 to keep the rectangle flush with the image. Finally, I need to scale the size of the platform blocks by multiplying by 3 and multiply the size of the platform rectangle by 3. Now that the window and all the game objects have been multiplied by 3, I can run the script and the result will be this. The height of the level is still 7 blocks tall and the width is still 8 blocks wide, but they aren't 32 by 32 pixel blocks anymore, which is why the level now seems gigantic compared to what it was, and it plays differently now than it did in the smaller window. With the blocks being this large on the map, Mario can't even reach the first platform. This wouldn't have happened if I had attempted to create a zoom effect, but I don't think there's anything wrong with having a larger level due to having larger platforms. It works just fine as long as everything is sized to the same scale, which obviously not everything in the script is, because this still doesn't really look like Mario. The blocks are way too big, so either Mario is the wrong size or the blocks are the wrong size. The image I have of Mario is 16 by 32 pixels. I'm pretty sure that is the correct size of the Mario sprite in the NES game. If he's 32 pixels tall, then the blocks can't be 32 pixels tall because that would make them the same height as Mario, which I'm sure we all know isn't how the blocks looked in the game. So if the image I have of Mario is the right size, then the image I have of the block is not. I'm pretty sure the actual size of the blocks in Mario is 16 by 16 pixels, not 32 by 32. So what I'm going to do now is take my script and change the starting size of the block to be 16 by 16 pixels and multiply that by 3, which should give me the correct size for the block compared to Mario. So in my platform class, I'm going to scale the image I have of the block to 16 times 3, and of course change the rect to 16 times 3, then change the total level width and height to 16 times 3, since the blocks are smaller now. Then I'll set the increment of the amount of X and Y to 16 times 3, so it will place the platforms based on the new size of the platform blocks. And I'll change the player's starting position to 16 times 3, so Mario will still start in the upper left-hand corner of the map. Now when I run the script, it looks a lot more like what a real Mario game would look like. This probably isn't the exact size of the screen in Super Mario for the NES, but everything on the screen is to scale, which is good enough for me. Now that all the game objects are scaled up, I can change the size of the window if I want, and it won't change the size of the objects, but I like the size of the screen in the Castlevania background, which is why I decided to go with it. Cutting the size of the platform blocks in half also cut the size of the level in half, although Mario still can't reach the first platform, but that can easily be fixed by modifying the level array. I could also modify the player class so that Mario can jump higher, but it kind of looks like he can jump plenty high already, so I'm going to go with modifying the level array. All I have to do to add a platform to the level is add the letter P in the level array, so I can make some steps for Mario to get to the first platform. When I run the script this way, I can actually kind of tell that Mario should really be able to jump higher, since I don't remember him needing a platform to be directly over his head for him to reach it. But hey, I'm not trying to create a perfect clone of Mario since I want to use this script to make my own game, so I'm just going to add a few more steps around the level to make sure Mario can reach all the platforms. Now when I run the script, Mario should be able to reach all the platforms, and we have a pretty good start to a 2D platformer. The size of the level looks pretty good, the scale of the level looks good, and the player looks pretty good. Although the player could look a lot better if he was animated, but I'll go over that in the next video. So I hope you enjoyed this tutorial, and thanks for watching.